Hello. So we have a problem where a block is acted on by a force that varies. So this is a very wordy problem, and it says varies as this value x for 0 is greater than less than or equal to x is less than or equal to 0.23 meters. And basically, what that means is and then remains constant at 4140 newtons for larger x. So basically, what that means is um, as as x goes from here to here, and this is going to be 0.23. So this is a x, and this is 0. This is in meters. So if while x is moving from here to here, it's going to rise by this number right here. Okay, let me just... And that is going to be our k. So it varies directly with this. And then from here on, it's going to be 4140 newtons. So the force right here, so it says the force right here is going to vary for this k times x. So that's what this is saying. So force here is going to, all right, let me use the same color so you don't get confused. So force here is equal to this thing right here times the x up until 0.23, and starting then on, from there on, force is equal to this value right here, so 4140 newtons. Okay, so with that in mind, let's try A. So the A is asking how much work does the force do on the block in moving it from 0 to 0.3 meters. Well, let's try to look at this problem graphically, and we'll delve into non-graphical, more algebraic method on part B. So in the next video. So so we have our nice little straight graph here, and the y value is going to represent force, and the x-axis, y-axis is going to represent force. The x-axis is going to represent distance, and this is in meters and this is in newtons. Okay, so what does this say? Well, from what we have seen before, it says the force varies directly with x. So this looks vaguely similar to y equals ma plus b without the b. So what's going to be our x value here? Well, it's going to be x, and what is going to be our slope? Well, it's going to be k. What's going to be our y value? Well, it's going to be f. So that's how I came up with these. So basically what the graph will look like is up until 0.23, the graph will rise in a constant manner. And the y value at this point, at 0.23, will be 4140 newtons. Right? And from there on, it's going to stay at 4140 newtons. Like this. That's the y value. Okay, so let's do A now. So how much work does the force do on the block in moving it from 0 to 0.3? So it's asking how much work it's done from moving it from here to, like, let's say here, if this is 0.3. So basically, in order to calculate work from this, it's just work is force times distance, right? So if this is distance and this is force, then we can just multiply this and find the work, right? So it's just actually the area under the curve, and so it's this area right here, and this is a vaguely weird shaped area. So I'm gonna try to divide that into simpler areas. So we have this rectangle here and a triangle here, and that should be easy to work with. So this is 0.30, by the way. So because it's the same thing, but just not to confuse you, just to show you that this one is larger than this one. Okay, so now we just have to calculate the total area in here. Okay, so let's try to calculate this area first. Okay, so what is our area of the square, of the rectangle? How do we do that? Well, it's just base times height. Now what is our base? It's 0.3 minus 0.23, and that's 0.07. That times the height. So what is the height? Well, it's 4140 newtons. So 4140. Okay, so that's going to be our area, whatever that value is. Okay, now let's calculate for the area underneath this triangle. Okay, triangle. So the area of the triangle is going to equal to 1/2 base times height. Okay, so 1/2 times, what's the base here? It's 0.23 times the height, which is 4140 newtons. So basically all you have to do here is you just figure out this value right here and figure out this value right here and just add it together. So our total area, let's just calculate that, is going to be this value right here. This is going to be 0.07 times 4140 plus this value right here. So 0.5, 1/2 times 0.23 times 4140. It's going to give us 765.9 joules, because we've defined that work is equal to the area under the curve, because work is equal to force times distance. Okay, and in the next video we'll see how we can derive an equation from this and try to solve part B more algebraically.